Okay, let's finish this problem. We've done our titration. Our little sorbic acid has been wiped out by the base. Found that it took 20.65 mLs net to do this. Let's see. The pH at the equivalence point of this titration is 8.83. We'd expect that. A weak acid and a strong base, you end up getting the equivalence point that's slightly basic because you've changed that weak acid into a weak base. And that weak base as present is going to elevate the pH a bit. Now say, which of the following indicators has the best choice of determining the endpoint of the titration? Okay, rule. The pKa of the indicator tells you which color is going to change. That's when the phenolphthalein negative log of 5 times 10 to the negative 10 is 9.3. So we've got a 9.3 for a pKa. In fact, let me use the magenta on this because that's the color phenolphthalein changes to. It's got this just magnificent color. One of my favorites of all of chemistry. So phenolphthalein changes at 9.3. The equivalence point is 8.83. That's close enough. It's certainly better than 7. And this is going to be the steep point of the curve, so it'll be close. Generally, when you use phenolphthalein, we wait for it to turn a really light pink, so that gives us more accuracy. So let's go on to the next one. That's simple enough. Indicator, pKa, change color. Calculate the pH at the half equivalence point. Okay, now half equivalence point. Now that's an important thing. That's if your AP exam doesn't ask somewhere about the half equivalence point, then you're not taking an AP chemistry test. Turn it in because it's, hey, somebody gave me a faulty test. Half equivalence. The titration took 20.65 mLs. So we know that half titration point is going to be half of that it's going to be in the area of 10. So we know somewhere around here, we're going to end up having the half equivalence point. But what's going to be the pH? We know that the full titration was 20.65 mLs. So answering their question, divide that by 2, and you get 10 point, yeah, depends how you want to run off, about 10.32 mLs. So I'm right about there. This is where our half titration occurred. So we've got the mLs that it occurred at, but what's the pH? Now here's the other rule that you got to remember. The half equivalence point, the half titration point, the Ka equals the pKa. And if you go back to the question, they gave you the Ka for sorbic acid. They said the Ka, the ionization constant, the ion product for that acid is 1.7 times 10 to the negative 5. Pretty close to that of acetic acid. That means that the pKa for sorbic acid, in fact, I'll pull up my little screen here and we'll take a picture of right now. There it is. Negative log of 1.7 times 10 to the negative 5 is 4.77. The pH at the half equivalence point is going to be that 4.77. So 4.77 is equal to the pKa. And when you have half titrated a weak acid, halfway there, the secret, the pKa, the secret of that acid is going to be there, 4.77. So all I've got to do is put an X there, about, say, at about 4.7 is going to be the half equivalence point. I've got the pH at 4.77. Yeah, here's 5, here's 4. That looks good. I've got the volume right. We're set. That's the half equivalence point. Now, let me draw the pH curve for this. We're starting off, this is a weak acid. In that little flask, we're down to a little bit less than 3 for our pH. We add some base to it, and man, it starts to react and the pH increases. But then the system becomes buffered. You got to remember, when the system is buffered, you're not getting much of a change in pH until finally the buffer is overwhelmed. And let me get my pen here, and it'll be like this. When they ask you to draw a buffered system, they'll expect a steepish curve at the very beginning, a buffered area, and then coming up again. Probably it would be a little bit smoother than this. In fact, let me just play it a second because this thing's got a line drawing that lets you put in some neat curves. Let me move that over here. And then I draw the rest of it. Do a little fiddling with the curves so it looks better, but this would be the final curve. So we're set. That's doing all of these. This would be a really, really tough question on an FRQ. Getting anything more than 7 points on an FRQ like this would be definitely 5 territory. Okay, that's it. I'm going to stop recording.